Hello and welcome back. This is another fifth grade math video. In this video, we're going to focus on how to identify equivalent fractions. Okay, so what we mean by equivalent fractions, we are talking about two fractions that use different numbers, but they represent the same amount. So for example, if I have the fraction that looks like this, I have 1/2. That means out of two pieces, one is shaded in. So half of that is shaded in. But what I can do is I can duplicate this, move it down here, and what I can do is divide it into more pieces. So let's say I divide it into a few more pieces here. So let's say I split this and I split this. And then I rewrite this fraction. So in this bottom fraction, I have two pieces that are shaded in out of four total pieces. But both of those fractions are equal to each other. They're representing the same amount of a whole that is shaded in, even though one says 1/2 and the other says 2/4. So 1/2 is equal to 2/4. So that's what we're doing today. We're taking a fraction and then we're looking for some different choices of fractions that use different numbers but are equivalent or representing the same amount. So let me delete that one and let's focus on our first one here. We're trying to find a fraction that's equivalent to 1/3. Okay, so there are a couple different ways to do this. For the first one, I'll use the first choice that we have, which is 3/9. 3/9. Now, the way that we can create equivalent fractions when we're not drawing a picture is to use multiplication or division. So I need to look at this to see if I can multiply 1 times something to get 3. And in this case, I can. If I do 1 times 3, that gives me 3. So if I can multiply the bottom by the same number, 3 times 3, and end up with this number, then yes, these two are equivalent. So I'm going to go ahead and circle 3/9 as equivalent. Okay, let's look at a different choice here. So we still have the 1/3, but let's see if it's equivalent to 2/6. Okay, so I know to go from 1 to 2 using multiplication, I would do 1 times 2. Now, if I do times 2 to the bottom, do I end up with 6? And the answer is yes, I do. So that means this one is also equivalent to 1/3. Okay, let's try another one. I'm going to delete some of this up here. Okay, so our next choice is 4/12. Okay, so let's see if I can figure out how to go from 1 to 4 using multiplication. If I do 1 times 4, that does give me 4. Now, if I do the same thing to the bottom, do I end up with 12? And it is true that I do. So 4/12 is also equivalent to 1/3. All right, let's check that last one, that last option. And that is 1/4. So to go from 1 to 1 using multiplication, I just multiply times 1. If I do 3 times 1 on the bottom, do I end up with 4? Nope, I should end up with 3. So that means 1/4 is not equivalent to 1/3. Okay, so here is our next one. We want to know which fractions from this list are equivalent to 8/12. So I'm going to go ahead and write 8/12 here. Now I'm going to show you another method you can use to determine if two fractions are equivalent. This one is called cross product or cross multiplication. What I do is I'm going to put my first choice, the 5/7 over here. If these are equivalent, when I cross multiply, I should get the same number. What that means is if I multiply 8 times 7, which is 56, I should get the same number when I do 12 times 5. Well, 5 times 12 is 60. So since I ended up with different numbers here, that means 5/7 is not equivalent to 8/12. Okay, that's called cross multiplication. So let's do another one. Oops, let me just erase this here. Okay, let's do, oh no, why did I erase the 12? Let's try that again. Okay, let me erase these. Okay, so I'm going to leave the 8/12, but this time I'm going to put 2/3 to see if this is equivalent. So I'm going to use cross multiplication, which means I'm going to do 8 times 3, which is 24. And then I'm going to multiply 2 times 12, which is also 24. So since I got the same number when I cross multiplied, that means that 2/3 is equivalent to 8 over 12. All right, let's try another. Let me erase some of these here. Okay, there we go. Another option is 4 over 6. So let's cross multiply. 8 times 6 is 48, and 4 times 12 is also 48. So that means 4/6 is also equivalent to 8 over 12. Okay, let's try that last choice to see if it's equivalent. Okay, so 8/12, and then I'll put 6 over 9 here. Okay, so 8 times 9 is 72, and 6 times 12 is also 72. So that means 6 over 9 is also equivalent. So from this list, the fractions that are equivalent to 8 over 12 would be 2/3, 4/6, and 6/9. That also means they're equivalent to each other. Okay, here's our next example. We're going to try to figure out which fractions from the list are equivalent to 10 over 14. So let's try this first one, 5 over 7. Now, I've shown you two ways to do this. The first one is to use multiplication or division to get from not numerator to numerator and denominator to denominator. The other one was cross products. Which one you use depends on what you're more comfortable with and which one you prefer, really. For what I like to do is when I set this up, if I can easily see how we go from 10 to 5 using multiplication or division, maybe I'll go that route. So since I know I could take 10 and divide it by 2 to get 5, I'm going to try taking 14 and dividing it by 2, and I do get 7. So that means that this is equivalent. So if it's easy for me to see the pattern of how I could go from one to the other, that's what I'm probably going to use. If it's hard for me to see that, then I would use cross product or cross multiplication. So 10 over 18 is our next choice. Well, I know to go from 10 to 10, I would have to do times 1. But if I do 14 times 1, I should get 14, not 18. So that means this one is not equivalent. Okay, let me erase those. Erase those here. Okay, so I'm going to put 7 over 8 here. So this is an example what I mean. Like this might be kind of hard for me to tell. I can't really divide 10 by something to get 7 or 14 by something to get 8. Doesn't mean they're not equivalent. It just means it's kind of hard for me to tell. So what I'm going to do is cross product. 10 times 8 is 80. And 7 times 14. Ooh, I don't know that one off the top of my head, but I do know that 10 times 7 is 70. And then 4 times 7 is 28. So if I add those together, I end up with 8 here and a 9 here. So this should be 98. Definitely not the same number. So that means 7/8 is not equivalent to 10 over 14. Okay, so let me do some erasing here to take these out of the way before we get to our next choice. Okay, there we go. Okay, let's check it against 8 over 15. So again, this one's kind of hard to tell. I can't really tell about 10 to 8 or 14 to 15. So I'm going to do cross product. I know 10 times 15 would be 150. Now 8 times 14, well, I know 8 times 10 is 80. And then 4 times 8 is 32. If I add those together, I get a 2 here and an 11 here. So not the same number at all. So we're going to cross that one off. So from this list, the only fraction that was equivalent to 10 over 14 was the first one, 5 over 7. Okay, here's our next example. We are trying to see which of these fractions is equivalent to 6 over 12. So let's try 5 over 10, our first choice. Now to go from 6 to 5 or 12 to 10 using division, kind of hard to see. So I'm going to go ahead and do cross multiplication. 6 times 10 is 60. And then 5 times 12 would also be 60. So that means 5 over 10 is equivalent to 6 over 12. All right, let's look at some of those other choices. Let me erase here. I'll do a bigger erasing here. There we go. Okay, is 6 over 12 equivalent to 2 over 8? Okay, this one's a little bit easier for me to see because I can go from 6 to 2 by dividing by 3. So if I divide 12 by 3, do I get 8? No, I don't. 12 divided by 3 should be 4, not 8. So that does not work. So that means 2 over 8 is not equivalent. Okay, I'm going to go ahead and clear up this one. There we go. Okay, next one is 7 over 14. Again, a little bit tougher because I can't really do 6 times something to get 7 or 12 times something to get 14. So let's do cross product. I'm going to multiply 6 times 14, which I don't know off the top of my head, but I do know that 6 times 10 is 60 and 6 times 4 is 24. So if I add those together, I get a 4 here and an 8 here. So that should be 84. 7 times 12. Well, I know that I probably should know that knowing my 12s facts, but I can't really recall it off the top of my head. So I'm going to do 10 times 7, which is 70, and then 2 times 7, which is 14. Add those together, I get a 4 here and an 8 here. Also 84. So voila, even those two fractions did not look like they were equivalent at all. They actually are. So I'm going to go ahead and circle 7 over 14 as well. Okay, let's do some erasing here, and then we'll try to figure out if our last choice is equivalent to 6 over 12. So I'm going to delete those. Okay, is it equivalent to 3 over 6? So for this one, I can more easily see that 6 divided by 2 is 3. So I'm going to try dividing the bottom by 2, and I get 6, which is exactly what the denominator is. So that means this one is also equivalent. So from this list, the fractions that are equivalent to 6 over 12 would be 5 over 10, 7 over 14, and 3 over 6. Okay, here is our last example. And for this example, what we're going to do is we're going to find the missing number that will make these two fractions equivalent. So right now, this is something over 5 equals 12 over 20. Okay, so I think for this one, because I can kind of easily see that 5 times 4 gives me 20, I need to figure out what times 4 would give me 12. And the answer to that would be 3. So that means the missing number that makes these fractions equivalent would have to be 3. All right, you guys, thank you so much for joining me today. I hope to see you in another video soon.